Hello my dear students, this is Surima. Today also in this session we will be solving some numericals related to the motion chapter. Okay, so those who haven't subscribed to my channel, please do subscribe to my channel, and also please leave a comment if you have any doubts regarding the session. And also don't forget to click on the bell icons so that you'll get notified next time I add a video. Okay, so let's start with page number 109 of your science text problems. Okay, these are numericals related to the motion chapter, and also basically these all are the applications of our equations of motion. We have learned the equations of motion in our previous lessons, right? So these are the equations of motion. There are three equations of motion, that is V is equal, the first one is V is equal to U plus AT, which gives us the final velocity, and second one we will get the displacement, which is equal to UT plus half AT square, and third one is 2AS is equal to V square minus U square. So our first question is, a bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. Find A, the speed acquired. Second question, the distance traveled. Okay, so whatever is given we'll write first. So best starting from rest, which means what? Initial velocity is 0. So we have U is equal to 0 here. And then with uniform acceleration of 0.1 meter per second square, we have acceleration is equal to 0.1 meter per second square for 2 minutes. So now we have T also. T is equal to 2 minutes. We'll convert it into seconds. 2 into 60. 2 into 60, that is 120 seconds. Okay. And now we have to find the speed acquired. What is the speed acquired? Speed acquired means the final speed acquired, that is the final velocity. We have to find speed and we have to find distance also. So you have U, A and T. So we can easily find V, no? So according to the first equation of motion, we have V is equal to U plus AT. That is U means 0 plus 0.1 into T, 120, which is equal to what? Which is equal to 12 meter per second. Right? 0.1 into 120 is what? We'll cancel this 0, then we'll get 12 meter per second square. So not second square, 12 meter per second. So now you have the speed acquired, that is 12 meter per second. Now you have to find what? You have to find the distance. What is the equation of distance? You can do 2AS. The third, according to the third equation of motion, we have V square minus U square. So what is S? V square minus U square by 2A. So we'll substitute. What is V? V is 12 square minus 0 square by 2 into 0.1. 2 into 0.1. So we'll do 12 into 12 by 2 into 1 by 10, no? So it will be how much? 6. So 12 6 are 72, and 72 into 10 is 720 meter. So the first case we have V is equal to 12 meter per second, and second case we have distance is equal to 720 meter. So moving on to our next question, that is question number 2. A train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. So we will write what is given first. A train is traveling at a speed of 90 km per hour. So our initial velocity is what? 90 km per hour. So we have to convert 90 km per hour to meter per second, right? Which is equal to 90 into 5 by 18 meter per second. So that is how much, which is equal to 9, 10, 9, 9, 2, so 5, which is 25 meter per second. Okay, so our initial velocity is 25. So brakes are applied. Okay, brakes, so our velocity is decreasing. So as to what is the acceleration of, so we have acceleration, how much? Acceleration, the velocity is decreasing, so we have minus acceleration per second square. Find how far the train will go before it is brought to rest. So it is coming to rest. So our final velocity will be what? Final velocity will be 0. So now how far the train will go before it is brought to rest means what? We have to find the distance. So now here we have to find the distance. So we have u, v and a. So what is the equation we have to substitute? That is we have to substitute the third equation, right? So because third equation is what? The position and velocity relation it's showing, no? So we have, according to third equation, what is that? 2as equal to v square minus u square. So what is s? V square minus u square by 2a. So now we will substitute and see. V square is what? V square is 0. So 0 minus, what is u square? U square is 25 square by 2 into minus 0.5. Okay, so minus and minus will be cancelled. Anyway, so we have 25 into 25 by 2 into 0.5 is by what? 5 by 10. So this 10 will go to the numerator into 10. Okay, so now we will do 5 to 10, 5s are 10. So 25 into 25 is what? 625. 25 into 25, which is equal to 625 meter. So S will be equal to 625 meter. So our train will go 625 meter before it is brought to rest. So you can write like that. Okay. So next question is question number 3. A trolley while going down an inclined plane has an acceleration of 2 cm per second square. What will be its velocity after 3 seconds? 3 seconds after the start. So whatever it is given, we'll write first. So trolley while going down an inclined plane has an acceleration. So a trolley was at rest first, no? So u is equal to what? 0. And it has an acceleration, it's going down. Okay, it's going down the plane. So it has an acceleration of 2 cm because it's increasing the speed, no? When something moves down, no, in the plane, inclined plane, it increases the speed, no? So our acceleration is positive. Acceleration is 2 centimeter per second square. Here centimeter is given, so we have to convert that to meter. How will convert? 2 divided by 100. Okay, so 2 divided by 100 is what? 0.02 meter per second square. So this is our acceleration. And then what we have? What will be the velocity after 3 seconds? After 3 seconds after the start. So time is given as 3 seconds. We have to find what? We have to find the final velocity. So what is the equation here? The first equation of motion, no? V is equal to u plus at. So what is u here? u0 plus 0.02 into 3, which will be equal to 0.06 meter per second. So this is our final velocity. Now our fourth question is, a racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after the start? So whatever is given, we will write first. So what it is, a racing car has a uniform acceleration of 4. So first one, the car is starting from rest, no? So we have u is equal to 0. We have a is equal to 4 meter per second square. And then what distance will it cover in 10 seconds? We have time is equal to 10 seconds. And now we have to find the s. So s we don't know. So what is the equation relating all these three? That is our second equation of motion. Okay, that is s equal to ut plus half at square, which is u means what? U 0 into which is u 0 into t is what? 0 only. Alright, 0 into 10 plus half a is what? 4 into 10 square. So 0 into this number will be 0. Half into 4 into 100, which is equal to 50. That is what? 200 meter. So before stopping, it will go what? The distance covered by the car in 10 seconds after start is 200 meter. Right? Okay, now we move on to the fifth question. This question is very important. Okay, so actually we have to read the question very well and understand it very properly, and then only you have to solve it. Okay, so I'll read the question. A stone is thrown in a vertically upward direction with a velocity of 5 meter per second. The stone is thrown upward. Okay, if the acceleration of the stone during its motion is 10 meter per second square in the downward direction, what will be the height obtained by the stone and how much time it will take to reach there? Okay, so here a stone, stone is thrown upward. Okay, stone is thrown upward, it reaches here. This will be the maximum height. Okay, so whenever an object is thrown upward, it comes down, right? You know, something is thrown upward, it comes down. Due to the gravitational force, it comes down. Okay, here the stone is thrown in a vertically upward direction with a velocity. So u is what? 5 meter per second. Okay, now we have u is 5 meter per second because it's shown here. 5 meter per second, it's thrown upward. Whenever it reaches in the maximum height, there it will stop and then only it will come down. Okay, so whenever some questions like this will come, something is thrown upward and then it come back, then our final velocity will be 0. So v will be 0 at that case. So here also a stone is thrown upward. Okay, and then with the velocity of 5 meter per second, when it reaches a maximum height, the velocity will be 0. Okay, that you should keep in mind. And then what is it? If the acceleration of a stone during the motion is 10 meter per second square in the downward, what is the acceleration in the downward direction called? Actually, that is the gravitational force, right? So that is the gravity, the acceleration due to gravity. Okay, so the acceleration due to gravity is what? 10 meter per second square. But now our body is moving where? Upward. Gravitational acceleration is downward. Okay, gravitational acceleration is downward, but our body is moving upward. So this acceleration is what? Is against the gravitational acceleration. So this will be negative. Okay, so whenever something is thrown upward, whenever it reaches maximum height, there the velocity will be 0 and then only it will come down. Okay, and the acceleration will be against the gravitational acceleration. So here the gravitational acceleration is given what? 10 meter per second square. So acceleration against the gravity is what? Minus of the given number. So minus 10 meter per second square will be our acceleration. So whatever we have, we'll write it first. Stone is thrown in a vertically upward direction with a velocity of, so our u is what? U is 5 meter per second. Okay, and if the acceleration of stone during the motion is 10 meter per second square in the downward direction, so that is in the downward direction is what? is gravitational acceleration, but our stone is thrown upward. So our acceleration is what? Acceleration is minus 10 meter per second square. Okay, you're clear, right? Okay, and now what will be the height attained by the stone? So what we have, okay, and v is what? Final velocity is, you know, when it reaches the maximum height, the velocity will be 0. So now we have to find the maximum height. Maximum height is what? Nothing but s, right? Distance. S we have to find, and then how much time will it take to reach there? So t also we have to find. So we have u, v, a. Now easily we can find t, no? What is that equation? V is equal to u plus a t. So what is t? V minus u by a. So t is equal to v minus u by a. So v is what? V is 0 minus u is 5 by minus 10. So minus and minus will be cancelled, and then we have 1 by 2 second, which is equal to 0.5 second. Okay, now the time is 0.5. Now we have to find s. So what is the equation? S, everything we have. Okay, s, v, a, t, everything we have. So according to third equation of motion, 2as equal to v square minus u square. So s is what? V square minus u square by 2a. So v square is what? V square is 0 square minus u square is 5 square by 2 into minus 10. Okay. So here 0 minus 5 square, that is what? 25 minus 25 by 2 into minus 10. So minus and minus will be cancelled, and then 5 2s are, okay, 5. So it will be 5 divided by, so it will be 1.25 meter. So the distance, the maximum height attained by the stone is 1.25 meter. You understood, right?